Hello everyone, I welcome you all again in this tutorial series. In this video, we are going to discuss about forward bias PN junction diode along with its characteristics and current equation. So here I am simply putting the heading as forward bias PN junction diode. अब पिछली वीडियो में भी हमने थोड़ा सा शॉर्टली देखा था कि we have two operation modes of diode. One is called as forward bias and one is called as reverse bias. So now in depth we'll discuss about that. Now what do we mean by forward bias? So when a p-type semiconductor is connected to positive terminal and n-type connected to negative terminal of a battery, such kind of junctions are called as forward bias junction. So here I'm just drawing a schematic for this particular forward bias PN junction diode. So here I'm taking a slice or material which is of p-type. So here it is a p-type semiconductor and we'll connect it with the n-type semiconductor. So here I'm just connecting this p-type semiconductor with the other material which is n-type semiconductor. So we have formed a PN junction diode. Now we have to connect it with positive terminal. So I am connecting p-type semiconductor with positive terminal and n-type semiconductor is connected to negative terminal of that. So this is positive, this is negative. So such kind of combination is called as forward bias PN junction. Now as far as its operation is considered, we know that as far as a p-type semiconductor is considered or n-type semiconductor, we'll concentrate first on n-type semiconductor. Here the majority charge carriers are electrons and basically electrons are negatively charged. So we'll place them like this. These all are the negative charged ions. So they are majority charge carriers. Now how they are majority charge carriers we have seen in the last video. अगर आप इस YouTube channel में first time आए हो तो just go through the videos, you will get a clear idea. So majority charge carriers are electron in case of n-type semiconductor. While in case of p-type semiconductor, we have holes as majority charge carriers, and they are going to be positively charged ions, or we simply calling them as absence of electrons. So I am putting it here. These are positively charged. So you can place in a way as per your wish also. So just place it like this. So here holes are majority charge carriers. Okay. So again, even though they are the majority charge carriers, but still we have electrons. They are minority charge carrier in p-type semiconductor, and in case of n-type semiconductor, we have holes as minority charge carriers. So there will be a small quantity of holes in n-type and small quantity of electron in case of p-type semiconductor. Now, as you've seen, an important point that has been we already discussed, all semiconductors are insulators. They are insulators, but at what? At 0 degree Kelvin. That means when we haven't applied any external voltage or temperature is not at all increased, they treat as insulator. Now when we go on increasing this value of this particular voltage, so what happens? These holes and these holes will repel each other because both are positively charged, whereas this is negative electrons and this is negative terminal. So again they will repel each other. So how actually the working principle takes place? So here when we increase the voltage, what happens? This positive terminal is connected over here and this is already positive, so both will repel each other. So due to repulsion, these poles will move towards n-type semiconductor. We call it as just pushing. Same case in case of this terminal. This is negative terminal. Now if this is negative terminal and here the majority charge carrier are electrons, electron both will repel each other, due to which this electron will collide with each other. You can see it like this one, and they will try to be a part of it. So I hope you understood. From here holes are entering into n-type semiconductor and from here electrons are entering into the p-type semiconductor. Now as we go on increasing this polarity, more number of holes will try to go into n-type semiconductor and more number of electrons will try to sandwich or shift towards the p-type semiconductor, and due to this here a region is formed. What happens? A region is formed, and where the concentration of both positive and negative charges will take place, and this particular region is called as barrier potential. So हम क्या बोलेंगे? Barrier potential. Barrier is nothing but it is an obstacle between this and this terminal, and due to the potential gradient of positive and negative charges, here a barrier potential arises. Now the value of barrier potential typically, I am writing it here, barrier potential is 0.7 volt. How much? 0.7 volt. Okay, so until and unless it crosses 0.7 volt, there will not be excess of current that flows from p-type to n-type or in one direction. यानी कि barrier potential जो forward bias PN junction diode का वो हो जाएगा 0.7. So when I start to increase voltage, voltage किस तरह से हम increase करेंगे? Let's suppose 0.1, 0.2, 0.3 and so on up to 0.7. What happens during this range? A small amount of current flows. What happens? A very small amount of current, flows. But when it crosses 0.7 volt, this barrier potential will break down and more number of holes will enter this region, more number of electrons will enter this region, and due to which there will be a sudden increase in current. So I am writing it here, the fourth point. After 0.7 volt, there is sudden increase in current takes place. Okay, and that particular area we can call it as breakdown region. Breakdown region. So as per as a diode is considered, the breakdown region plays an important role. Similarly, the barrier potential also plays an important role. I hope you understood whatever we have studied till now. So what we have seen, p-type, n-type connected with positive and negative terminals, it forms forward bias PN junction diodes. All semiconductors are insulated at 0 degree. That means at the given temperature. Once we start to increase the temperature or voltage, what happens? More holes will try to enter n-type, more electrons into p-type, due to which here a barrier potential has been developed. That term is called as barrier potential, and its value is typically 0.7. Now once we cross 0.7 volt, this particular region will break down. This is we call it as a breakdown region also, and more and more holes and electrons will combine each other, due to which there will be a sudden increase into the current. So this is the point that we have studied up till now. Next, in case of forward bias, the current, I am writing it here, current is denoted as IF, that stands for forward current. Remember, it is always measured in milliamp. Most important. Forward bias current will always in a form of what? It is measured in terms of what? Milliamp. So this is about forward bias PN junction type. Now when we come across its VI characteristics, it's become important to study about VI characteristics also. So as far as VI characteristics is considered, it is basically a graph. What is it? It is basically a graph between applied potential, which we measure in terms of V, and produced current, that is I. Now here, as we are dealing with forward bias, I am abbreviating it as IF, that stands for forward current. So as soon as we goes on increasing the voltage, there must be increasing the current. That relationship is called as VA characteristics. Now here the values, initially it will be 0, then it may be 0.1, 0.2, 0.3, subsequently when I come across 0, 0.7 and so on. Accordingly we have to check its performance. Now recently we have seen that there is a barrier potential and whose value is 0.7. That means when I apply voltage 0, there will be a very small amount of current that flows through the circuit. So it may be negligible, around 0 milliampere. Same remains till the voltage applied is greater than 0.7. So you can see it here. I have drawn this sharp curve that indicates that there is a small increase in the current. Current values are plotted on y-axis. There is a small increase in the current values until it reaches 0.7 volt. Once it crosses this, there will be a sudden increase in the current. What is it? There is a sudden increase in the current values, and this region is called as breakdown region, and this value is always in milliamp. So such characteristics are called as VA characteristics in forward bias. Now this 0.7 volt is also called as knee voltage. It is also called as what? Knee voltage, which has a value of 0.7 volt, or this is also called as turn on voltage. It is also called as what? Turn on voltage. Remember, these are the quite important points. Knee voltage in forward bias has a typical value 0.7 volt. Knee voltage is also called as what? Turn on voltage. Why? Because it is turning on or simply turning on the conducting properties after 0.7. So accordingly it is called as knee voltage or turn on voltage also. Okay guys, so I hope you understood the basics of forward bias PN junction type. Now we'll go on to see the current equation of forward bias PN junction diode. So the forward current, typical formula I am writing it here. Forward current equation is given as IF is equals to I naught into e raised to V divided by neta Vt. This is basically neta Vt minus 1. This is a standard equation. Now as there is no need of going in depth how this formula has been organized, we'll note it down directly. I naught e raised to V by neta Vt minus 1, where this I naught is called as reverse saturation current. What is it? It is a reverse saturation current. What is reverse saturation current is not that much important for your discussion, but let me tell you, in case of PN junction diode, we have minority charge diodes, and this minority charge diode will constitute a small current, and that current is called as reverse saturation current. Next, Vt is basically called as thermal voltage or volt equivalent, which has a value 26 millivolt. Remember, it's important point. Thermal voltage is 26 millivolt, but at 300 degree Kelvin. So you may get a question like this one. The value of thermal voltage of diode is, what is its typical value? 26 millivolt, but at what? 300 degree Kelvin. And the value of neta is depending upon the material that we are using. So typically it has a value of 1 for germanium material, and it has a value of 2 when we use for silicon material, again at 300 degree Kelvin. So this is all about the forward bias PN junction type. I hope you understood this concept. Now in the next video we'll discuss about reverse bias PN junction type.